Hello everyone. In our previous video, we understood the basics required for deriving the logistic regression equation. So in this video, we'll try to understand how to derive the equation. All right. So we know the log of odds is equal to log of p by 1 minus p. So ln is another representation of the log, right? So we know very well, right? The formula for linear regression equation is f of x equal to mx plus c. So in our case, we know what is f of x. It's nothing but log of p by 1 minus p, which we can write as log of p by 1 minus p equal to mx plus c, right? So now we'll apply some linear algebra on top of this formula to derive our logistic regression equation. So now, if we, as I said, right, we need to apply some algebra knowledge here. If we move the log function to the other side, it will become the exponential, which we already discussed in our previous videos, right? So now, before the equation of log of p by 1 minus p equal to mx plus c, now we move the log to the other side, it becomes the exponential, right? So which is nothing but e to the power of mx plus c. Now we'll be sending our denominator, which is this 1 minus p, to the other side. It will become p equal to 1 minus p into e to the power of mx plus c is nothing but our exponential, right? So which in turn we can write as e to the power of mx plus c minus p into e to the power of mx plus c, right? So we can write our previous equation as below, right? So if I send this minus p into e to the power of mx plus to the other side, it will become p into 1 plus e to the power of mx plus c, which in turn we can write as p equal to e to the power of mx plus c divided by 1 plus e to the power of mx plus c. We can also write the above derived equation as p equal to 1 by 1 plus e to the power of, which is exponential to the power of, minus mx plus c. So this is our logistic regression equation. So now we'll try to understand how this equation is derived from the above equation, right? So what I'm doing is, so we need to divide our derived equation and both numerator and denominator with e to the power of mx plus c, right? So now if you see this is how it is, right? E to the power of mx plus c divided by e to the power of mx plus c divided by 1 plus e to the power of mx plus c divided by e to the power of mx plus c, which will in turn will get this formula. How we'll get is, now we know, right? So I can write 1 divided by a as a to the power of minus 1, which is like 1 divided by a square equal to a to the power of minus 2. If you want to send the denominator value to the numerator, you'll add minus 1 to the power, right? As I said, 1 divided by a is equal to a to the power of minus 1, right? So we understood, right? So in this formula, right, so I can divide this 2, so which will become 1. Now we are just trying to understand the denominator, how we got this value, right? So now I took only the denominator here, which is 1 plus e to the power of mx plus c divided by e to the power of mx plus c. Obviously, right, as I said, if I send this denominator e to the power of mx plus c to the numerator, so yeah, it will become e to the power of minus mx plus c plus e to the power of mx plus c into e to the power of minus mx plus c, right? We know, right? So a into a to the power of minus 1 is nothing but a divided by a, which will be 1, right? So that's how in the denominator we'll get e to the power of minus mx plus c. Got it? So hope you enjoyed this video. In our upcoming videos, we'll try to understand the different sampling techniques, and we'll also try to understand the very common problem in the classification world, which is like how to deal with the imbalanced data. Don't worry about what is imbalanced data, which we'll cover in our upcoming videos. And we'll take some classification problem data, and we'll try to train our model using logistic regression. So stay tuned. Please don't forget to subscribe my channel. See you in the next videos.